Hey guys, Mr. Gucci here with some God, what unit are we on? 12, yeah, Unit 12 review. In this video, we're going to work on questions 8 through 11, some simple single-step problems. All right, in the meantime, Newt, my cat's trying to eat my yogurt. Okay, anyways, let's get to it. All right, so question 8. When 425 joules of heat is added to 3.4 grams of olive oil at 21 degrees Celsius, the temperature increases to 85 degrees Celsius. What is the specific heat of olive oil? So let me get a blank page to work on. All right, so here we go. So in starting this problem, we have to ask ourselves, which of the two energy equations are we going to use in this problem? The first one over here on the left, Q equals mc delta T in yellow. This is an equation that's useful for calculating heat that causes a change in temperature. All right, this delta T is a change in temperature. On the other hand, this equation on the right here is the energy needed to change something's state of matter. And this delta H is the heat of phase change. All right, so looking at problem 8 from the review, we see that this substance's temperature is increasing from 21 Celsius to 85 Celsius. That is a change in temperature. So we are going to use this equation in question number 8. Now, because I've written it up here, I'm not going to skimp. I'm still going to write it. Q equals M times C times delta T. And now let's start filling in this problem. All right, I assume you're looking at your paper so I don't have to keep going back and forth. All right, so this problem says that 425 joules of heat energy is added. That is Q. So you are given Q in this problem. It's 425 joules. Okay? You are also told the mass. This is 3.4 grams of olive oil. All right. You are not given the specific heat. You are asked to solve for it. So we're going to put in a C there. Actually, I don't like that. I don't like that color. La 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 la. Purple. Yeah. All right. We're going to put in a C. And lastly, the change in temperature. Well, it went from 21 degrees to 85 degrees. So I'm going to do a little work over here. 85 minus 21 equals 64. So that was a change in temperature of 64 degrees. All right, so we have got to solve for C, which means getting it by itself. C is being multiplied by 3.4, so we're going to divide both sides by 3.4. And C is being multiplied by 64, so we're going to divide both sides by 64. And we'll get our answer. 1 second, I'm going to calculate it. All right, using my calculator, I got that the specific heat is equal to 1.95 joules per gram degrees Celsius. Let me write this a little bit neater here, all right? The specific heat, C, is equal to 1.95 joules per gram degrees Celsius. Now that is the unit for specific heat, all right? The way you can think of it is in terms of words. For oil, the specific olive oil here, it takes 1.95 joules to raise a gram of this oil by a degree Celsius. So that is the specific heat. All right, very good. On to the next one. All right, so in problem 9, how much heat is required to raise the temperature of 250 grams of mercury to 52 degrees from 25 degrees if the specific heat is 0.14? So hey, another example of a temperature change problem. So we are going to use Q equals mc delta T, because there is that change in temperature in the problem. So let's get to it. Now, problem 9 is actually pretty straightforward. It's asking us to solve for the heat energy. So we're solving for Q. Okay, the mass of the mercury is 250 grams. The specific heat of the mercury is 0.14 joules per gram degree Celsius. It takes 0.14 joules to raise a gram by 1 degree. And the temperature change, it goes from 25 degrees to 52 degrees. So that's a total temperature change of 27 degrees. So this isn't even really algebra, folks. You just got to multiply together because Q is already by itself. So here we go. 250 times 0.14 times 27. And what I get is that this mercury requires 945 joules of energy. All right, good. On to the next one, number 10. All right, a 45-gram substance has the specific heat of 0.86 joules per gram degree Celsius. If the temperature changes from 25 to 37 degrees Celsius, what amount of heat in joules has been added to the substance? Well, this is another Q equals mc delta T, because there is a temperature change. Now, much like problem 9, it asks us for the energy. So we're solving for Q. So this is going to be another easy one. Let's hammer it out quickly. All right, 45 grams, that's the mass. The specific heat of this substance is 0.86 joules per gram degree Celsius. And the temperature goes from 25 to 37. That's a 12-degree change. So how much energy did this substance absorb? 45 times 0.86 times 12. We got 464.4 joules. All right, there we go. Is there ever going to be the other type of problem, Mr. Gucci? Yeah, sure, why not? Here we go. Problem 11. How many grams of ice at standard conditions can be melted by the addition of 6,400, that should say joules of heat. Should say joules. All right. Let me double check here, make sure it says it on this packet forever and all time. Yeah, okay. So here we go. How many grams of ice can be melted? Melted. So this is a phase change problem. The energy absorbed by the substance is equal to the mass times the heat of phase change. So now in problem number 11, you're given the energy Q. This substance absorbs 6,400 joules of energy. You don't know the mass. You're trying to solve for that. And the specific, or the heat of phase change, well, what we know is that this is ice that's melting. Hey, you know what? This is actually a great opportunity to show you something that you're going to be getting for your final exam and that I've just uploaded here. This is the equation sheet that you will be getting for your final exam. All right, it's got some of the gas law equations, it's got the activity series, all right, it's got the solubility table, and it's got thermochemical equations and values. All right. So this is where you would look to find that information. And if during the test you were confused, this is a totally a situation where you could ask me where you'd find the information and I would tell you where it was located. So we're talking about melting ice. So that's not solidification, that's freezing. That's not condensation, that's condensation. And it's not vaporization, it's fusion. So the energy it takes to melt ice is 333.3 joules per gram. So here I go. It takes 330 fusion 33.3 joules per gram. So to solve for the mass here, I'm going to divide both sides by 333.3. So the mass of ice that can be melted with this many joules is, I got 19.2 grams. That's how many grams of ice you can melt with that many joules of energy. And that's problems 8 through 11. All right. Thanks, guys.